on section 3.3, the derivatives of products and quotients. And are you ready for notes? Ready to start? Let's go. Let's do this. And by the way, those recordings you could and should go back to if you need to, go back, listen to them. Do it 15 minutes at a time, or maybe one question at a time. Just a suggestion, especially if you're having trouble sleeping, I strongly recommend that right before bed. Because there's a rule. It says you will remember everything you do just before you go to sleep and the first thing you do when you wake up. Guaranteed. So, all right, here we go. So we're going to start with product rule. So it's basically theorem 1 in this chapter. And it's dealing with products. And I'm going to simplify this as easily as I can. So it's the product rule, actually, not products. Product rule, a bit more formal. Okay, and now let's make it easy. Imagine a function, like you have a y equals some f of x, where f of x is a function itself, right? And that function is the result of two binomials or a single term and a binomial multiplied. So hence a product, right? Two things multiplied together. So in product rule, the way it works is the derivative of y, or the first derivative of that function, is going to equal the first term in the product times the derivative of the second term, just like that, plus the second term itself times the derivative of the first term. Okay, before you lose your mind, I'm going to show you how to do this the easiest way possible. There is more notation to be had, so let me show you that notation. The shorthand notation is if I have y prime, that's equal to f times s prime plus s times f prime. That's the shorthand notation. And you may also see it as dy over dx is equal to the first term, or the first binomial, times ds over dx, in other words, the derivative of the second term, plus the second term times the derivative of the first. So all of these are ways that you can see this notation. The easiest way that I can show you this is if I'm going to give you, okay, so let me give you this example 1, and I'll give you a couple others after that. So we're going to find or differentiate f of x is equal to 2x squared times 3x to the 4th power minus 2. Now keep in mind that if I were to color code this for you, f of x is this. S of x is simply all of this. Okay? Now, right underneath it, what we're going to do is we're going to write this down as f of x is equal to 2x squared, and we know that that derivative, right, from the first test is equal to 4x, and we know that. The s of x, we know this is simply 3x to the 4th power minus 2, and so its derivative is simply 12x to the 3rd power. Do you see where this comes first? And I look at how I'm drawing the arrow. I'm drawing this as a product going this way, because that goes to the left, plus this product going to the right. So if I write this out correctly, this is simply going to be 2x squared times the derivative 12x cubed of the s term, or the s function, plus the original s function, which is 3x to the fourth power minus 2, times the first derivative of the first term, or the first function, at 4x. You want to see the color code? Follow the color code. Let's do yellow. Yellow is our 2x squared, right? And that goes here. The orange is going to be its derivative, which is over here. In blue, I have the original 3x to the fourth power minus 2, which is right here. Its derivative, which is going to be right here. In green, 12x cubed. If you can remember that, that is basically how we calculate the first derivative of a product function. Now there is a second method we can use, which once we distribute this and collect like terms, we're going to end up with 36x to the fifth minus 8x. If you need to see the middle step, I'll do it. If you don't, I'll continue. You tell me. Do you need to see the middle step? All it is this product and this product, and gather like terms. So just in case, you know what? Let me not skip steps. We know that this results in 24x to the fifth, and this part will become plus 12x to the fifth minus 8x, which is how I'm combining this to get 36x to the fifth minus 8x. Okay? You with me? Now, there is an easier way, and I want to show you that as well. So I'll tell you what, I'm going to do it right here on the side. It's another process. We know how to differentiate. If I multiply 2x squared times 3x to the fourth, I'm going to get 6x to the sixth power minus 4x to the second power, aren't I? Well, we know how to differentiate, right? Isn't this simply 36x to the fifth minus 8x? That's two steps. 2 seconds. All right, if you want to try one, let's do one on our own. And I'll put it here. We'll call it the try question. So I'm going to give you f of x is equal to 3x to the third times 2x to the second minus 3x plus 1. And I want you to find either method, I don't care, find the first derivative.
Which method should we use?
Whichever one you're comfortable with. Technically, I think you should learn both. The same. So what did you get? 30x to the fourth power. Fourth? 4, yeah. Okay, yes, you're right. Minus 36 x cubed. So if we use the distribution method, which is very easy, you're going to get, in this case, you're going to get 6x to the 5th minus 9x to the 4th plus 3x to the 3rd. Do we agree on that method?
Yeah.
And that's just the product. That's not even the derivative yet. The first derivative now is simply differentiation of this type, which is 30x to the 4th minus 36x to the 3rd plus 9x to the 2nd. I know you missed something there, but it's good. All right, so that's doing it the short way. Doing it the long way, again, we start with f of x is equal to the 3x cubed. Its derivative is 9x squared, correct? And then s of x, well, that's going to be our original 2x squared minus 3x plus 1. And its derivative is simply going to be 4x squared minus 3. So if we follow the rule and go multiply those two and then add the product of those two, so we should have 3x cubed times the derivative of the second equation, so 4x squared minus 3 plus the 9x squared as a product times 2x squared minus 3x plus 1. All right, and then we're going to distribute, so you get 12x to the 5th minus 9x to the 3rd, 12x to the 5th minus 9x to the 3rd plus 18x to the 4th minus 27x to the 3rd plus 9x to the 2nd. Now we want to combine like terms. Okay, we combine like terms. We have 12x to the 5th plus 18x to the 4th minus 36x to the 3rd plus the 9x squared. Okay, and now we differentiate, because remember, this is just derivative.
Yeah. Of x is 4x minus 3. No,
What did I
4x
put?
is second power.
Yeah, y is square.
Where are we looking?
Derivative of the second one.
This one here?
Yeah, when you get 4x, not 4x squared.
Yeah, because you.
That makes a huge difference. That makes a huge difference. So in this case, then this has to get eliminated as well,
So
and that changes our answer completely. So let's go back. Whee! I was looking at it and I'm like, this is not gonna add up. This is not gonna add up. What's going on here? What did I do wrong? Okay. So yeah. So 12x to the 4th minus 9x cubed. And this is plus 18x squared minus 27x cubed plus 9x squared. Okay, now let's combine like terms. Where are we? It's 18x to the 4th. Look at you paying attention. Because you know I do that on purpose. I just want you to know that.
Yeah, of course.
Of course. Okay, so what happens here? We end up with 12x to the 4th minus 36. No, okay, what is wrong with me? What drugs am I on today? This is 30, thank you. So it's this term and this term. Okay, and those two added together, 36x to the 3rd plus 9x squared. There you go. It should match what we have up here, which it does. Okay. Was that okay for most of you, I hope? Yeah? Right. Okay, the second example I have for you here, or the second notion, is how do we use this? So that we have example 2, which is all about tangent lines. So I'm going to put that there to follow. So tangent lines, they're going to start us with letting f of x equal 2x minus 9 times x squared plus 6. So obviously we can differentiate that and find its derivative easily. For part A, we have find the equation. So find the equation of the line tangent to the graph of f of x is equal to 3 at x equals to 3. All right, so that's the first part of what they're asking us. So we could use simple differentiation rules if you want. So we could do, like, for example, f of x, which is equal to 2x minus 9. That first derivative is simply equal to 2. The s of x, which we know to be x squared plus 6, its derivative is simply 2x. And so again, if we use this process where we cross multiply and add the product on the other side, you end up with 2x minus 9 times 2x plus x squared plus 6, all of that times 2. All right, and so since we're first going to do f of x, which is just the product, if you want to do that, we could up here, since they give us this value up here. Okay, so this as a product, if I substitute in 3, 2 times 3 minus 9, well, that's going to give us minus 3. And we substitute in 3 squared plus 6, this will be 15. So negative 3 times 15, we know that this will be negative 45. Okay, and now over here, if we use our products, we could just plug it in at this point. So that basically, again, this is negative 3. Plug in 3 here, this is 6. Plus, as a value, this is 9 and 6, so 15. And this is times 2. So we end up with negative 18 plus 30 equals 12. So we have two values. They're asking us to find the equation of the tangent line when x is 3. So here's what we do know. Based on this, we know that y minus 45 is equal to 12, because that's what we got here. That's our slope. Times x minus 3. We get that from here, up here. Now we solve. So we have y plus 45 is equal to 12x minus 36. And if we subtract the 45 on both sides, we end up with our equation, which is basically y equals 12x minus 81. And that's the tangent line at x equals 3, which answers our question. Okay, because remember, the key is this is y, this is highlighted at 3. Now, the part B in this question says find the values where x is horizontal. So basically we need to factor. So find the values of x where the tangent line is horizontal. If it's horizontal, what does that tell you about the slope?
There's no slope.
Well, 0, right? So we could factor this. So if I take that first derivative, let me go back. I'm gonna make some room this way. So that first derivative is equal to 0, if that's the case, by definition, right? So we're gonna take that f prime x, that first derivative, which is 2x minus 9 times the 2x plus the x squared plus the 6 times 2, and we're going to set that to 0. So we have to distribute and then factor. So let's see. So if I simplify this, this will be what? 4x squared minus 18x plus 2x squared plus 12. All right, and that's equal to 0. Put that together, we get this value and this value gives us 6x squared. We're left with a negative 18x, and we're left with a positive 12 equal to 0. Now, keep in mind 6 goes into all three of these, so if I divide all of these by 6, including the 0, doesn't matter, that means that I could factor this out, leaving me x squared minus 3x plus 2 equals 0, which means that I can factor that further, right? So this is 6 times x minus 2 times x minus 1, set that equal to 0, which means that x is equal to either 1 or 2. Fair enough? Believe it or not, this goes back to, there's a course that they teach at FAU, and if any of you are going to do a master's or even take courses at FAU, I think it's called, I want to call it, it's an MG something course, 3600. It's a business decision analysis or business decision making. You'll see this type of math. Basically, if x is 1 or 2, you're a flat line. You're not making money, you're not losing money. You know, there's a whole analysis process with it. It's a really interesting course. Do you want to try one like this? If I give you different numbers? All right. So, same question stems. But I am going to change this. This is going to get switched out, and we're going to make this f of x is equal to, let's make it 2x minus 9 times x squared minus 12. And we're going to repeat the example. So if you want, we could just start with part A. So everything is the same up to until the 3. X equals 3. Just different equation. I'll give you a couple of minutes to get set up.
equal to 3.
Hmm?
The first example on the left, where did you get the 2 from and the 2x?
A first derivative. So this is, you talk about this,
Yeah.
that's the derivative of this. And if you look at this one, this is the derivative of this.
How did you get the, you get in 45?
Plug in the 3 into the equation. So 2 times 3 is 6, minus 9 is negative 3. And then 3 squared plus 6, that gives you 9 plus 6, which is 15. Negative 3 times 15 is negative 45.
And for this new equation, it's the same, x equals 3.
Yeah, we're going to use x equals 3. So if I start with that process, 2 times 3 minus 9, that's going to give me the same negative 3. And this is going to give me also negative 3, because this is going to be 3 squared is 9 minus 12 is negative 3. So this actually will yield me a positive 9. It's going to be my answer for that part. And if you want, I'll do the derivative on this side by just differentiating. So 2x times x squared is simply 2x cubed. 2x times negative 12 is negative 24x minus 9x squared. Could this be more convoluted? Really? Minus 9x squared. And then the last part is 9 times 12. Hmm? 108? Positive 108, yeah. Now we have to differentiate. So this is 6x squared. So in other words, this is the derivative. 6x squared minus 24 minus 18x plus 108. Oh, actually, what am I on? No 108. We're differentiating. So at this point, this is going to give us a slope. So 6 times 3 squared minus 24 minus 18 times 3. What do you get there? So this is 54 minus 24 minus
54.
This is 54?
Yeah.
So the final answer, negative 24. So that's your slope. So you have your slope, you have your y term. So this becomes, based on our previous value, this is y minus positive 9 is equal to negative 24 times x minus 3, because remember we use the same value. If you want to do it in yellow just to remind you. And so distribute. So you get y minus 9 is equal to negative 24x, and then what do you get here? 24 times 3 plus plus 72, so then add the 9 and bring it over. So you should have a final answer of y equals negative 24x and 81.
So I have a question. How did you get the top f of x, 2x cubed minus 24x minus 9x squared plus 28? Because I have a different equation, but I have the same answer. M equals negative 24.
So we use the 2x minus 9 times the x squared minus 12.
Okay.
That's what we have. And so 2x times x squared.
Oh, I see what you did.
Yeah.
You
This is the minus 24x.
okay.
That's your negative 9x squared. And this times this is positive. You said it's 108.
Yeah. Okay, so I what I did was the long ways. The
Should have gotten the same answers.
So that's okay.
And this is just the f of x. We're not done with f of x, so we have to now differentiate.
Right.
This is where we get our 6x squared minus 24. This gives us negative 18x, and this cancels because it's a constant. So if we plug in the 3 squared is 9, 9 times 6 is 54. Drop the 24, and then 18 times 3. Yep. You get negative 24. Okay, if you're comfortable with that, I want to continue with example 3. All right, example 3. This also deals with finding derivatives, but this time we're bringing the e to the x back and the natural log x. So in example 3, I have f of x is equal to 2x cubed e to the x. Okay, so do you remember how to differentiate that is the question.
Yes.
So what do you think the answer is to this?
6x squared e to the x.
Remember there's an f of x, which in this case is 2x cubed.
Right.
And there's your s of x,
Yeah. Okay.
which is e to the x.
Oh, okay.
So the derivative of this s of x, remember the derivative of e to the x is simply
E to that.
e to the x. The derivative of this f of x is simply 6x squared. So if you remember, cross multiply.
Oh, okay. I don't know. My bad.
So if you follow this pattern for this type, which I recommend, I would then realize that this is actually 2x to the third e to the x plus e to the x again, right? Because it's the first term, times, and then this would be your 6x squared. Technically, there's a 2x cubed. I take that back, a 2x squared. Because if you notice in this function, this is a common term. The 2 is common to both as well. So there is an x squared here. So I can technically take out 2x squared. And I can also, my apologies, I can also take out an e to the x. If I'm looking at the whole picture. This ends up being x plus 3. And that's your first derivative. So remember, you do factor out whatever is common. Right. If you want, let's try a second one of these and let's see if it sticks. So I'm going to give you f of x is equal to 5x to the 8th e to the x. I would use the four method, 4-term method, I should say. Okay, so we write it out with the f of x and s sub x, or s of x, we get 5x to the 8th, and this is simply the e to the x part. We take the derivative of the f of x. This gives you 40x to the 7th power. This s of x, its derivative is simply e of x. So if we cross multiply, this will give you 5x to the 8th times e to the x plus 40x to the 7th times e to the x. I'm writing them in the same order this time, now that I hope you feel more confident. Because remember, this is technically the derivative part. I hesitate doing that, but what is common to both, if you look carefully, you have the 5 goes into 40, x7 goes in here also.
Okay.
All right, so let's take out the 5x to the 7th times e to the x, so they both have an e raised to the x, and this leaves you with
X
x plus
plus 8.
8. Yeah, there you go. If I multiply that back, it comes back.
Like I get the first part, how you are, it would get 5x 7 times e to the x, but I don't get the in parentheses part, what's x plus 8.
Okay,
The parentheses would be like, if you were to divide 5x by 8 and 4x by 5.
right. So 5 goes into 5 one time, which is this
Okay.
this coefficient here.
Right.
This is 5x to the 8th, this is an x to the 7th, hence x to the 1 stays inside.
Okay.
I cannot take more than what I can borrow.
Okay, that makes sense now.
The e to the x, obviously that's common, right?
Right. Yeah.
This common, you can see it in both. And then the last piece is just the 40. 5 times what gives me 40?
Okay, that's okay. Thank you.
Yeah.
That's,
Because remember, there's a big old plus sitting right here. All right.
that's the one.
Okay, let me show you example B of this type. I'm going to give you f of x is equal to 6x. Give us a.
So if you can go back to, how do you get the 8 and the x plus 8?
5 times 8 is 40.
So,
Basically I'm taking this out and I'm dividing. Okay, so imagine if I have 5x to the 8th here, e to the x, plus, okay, I'm going to make it really obvious, plus the 40x to the 7th, and then e to the x. So my question to you is, what is common to both terms? 5. I can divide this by 5, and I can divide this by x to the 7th. I can divide this also by e to the x. I can divide this by 5, x to the 7th, e to the x, because both are common. So if we do the math, if I take out 5x to the 7th, the way you need to start thinking about this is, go back here. 5x to the 7th times what is going to give me 5x to the 8th?
Yes.
All right, I'm missing the e to the x because I took it out. So I'm going to put it back here. So it also got taken out. So if I take that out, I'm left with just x to the 1. Plus, the big old plus. Okay, again, we're going back to this. If I already took out an e to the x, I don't need to repeat that process here. 5x to the 7th times what is going to give me a 40? Yes? Capiche? Like, really? Okay.
It's amazing how sometimes we forget the most simplest things once we learn
Oh.
something so complex.
I can fix a VCR and I'll sit there and curse the world apart, hitting the button. And you know what I forgot to do? Plug it in. That's happened to me at least twice in my lifetime. But I'll fix the VCR. Okay, so I'm gonna give you this one. See if you can find the derivative. Notice it is a product. They probably won't even put the little dot in between, so I'm going to take it off. Okay, so working this out with you, here's what we do know. We know that the f of x part of the product is 6x to the 4th, and we know its derivative is simply 24x to the 3rd. Agreed? We also know that s of x is equal to natural log x, and we also know that its derivative is 1 over x. Good. So we're going to cross multiply this and this. I'm going to color code it so you can follow a little easier. So the first term is 64 x to the 4th times the 1 over x plus the second term is simply the natural log of x times the 24 x to the 3rd. That's what we have so far.
Are you sure it's 64? Yeah, you lost me at 64x to the 4th.
I lost you at 64x to the 4th.
When we're only doing 6x.
I don't know where 64 came from, so stop channeling. I'm telling you right now, stop channeling. No, okay, it's just 6x to the 4th.
Wait, what?
Just trying to make sure you're paying attention, that's all, man. All right. So naturally, this is an x to the 1 power. If I multiply these together, isn't this really just 6x to the 3rd? Okay? Because this is x to the 1 down here. If you're missing the memo, look up here for a minute. This is 6x to the 4th over x. Isn't it? If I multiply? So that reduces here. So this is plus, and then now we have 24 x to the 3rd times natural log, no change there. And can I take something out? Is there something common to both? 6, keep going. 6x to the 3rd, yes. So this becomes 1 plus. Almost did that. And that was not a mistake. That was actually legit. X plus 4 natural log x. Right? Capiche? Capiche. Would you like to try another one on your own? Let's do one? Yeah. Okay. So try this one. So I have f of x is equal to x to the 7th natural log x. Give that a shot. So far, are we matching?
Mm-hmm.
So this will be x to the 7 times 1 over x plus, and this next part will be natural log x. I don't really like doing it that way. Let me just do it this way. So we're going to do 7x to the 6 times natural log x. That helps a little bit. All right, and so now this reduces to,
X to the 6.
this is just x to the 6. Uh-huh. Mm-hmm. Plus what?
7.
Okay, is there something I can take out that's common? If I take out x to the 6, am I going to end up with what? 7 natural log 6. Good. You feel confident with that? Okay, let me continue with, okay, so I'm going to introduce a second way of doing derivatives, and in this case we talked about product rule. The next one is quotient rule. So this is theorem 2. This is quotient rule. Okay, and in quotient rule, unlike the product rule where you have multiplying two things, here we're simply dividing two things. So if I have y equals f of x, then this notation would look like this, where f of x is this function divided by this function. Now you can use long division to obtain a normal value with non-e or natural log, like regular terms. You could do that, but it doesn't work that well when you have e to the x or natural log. So let's avoid that for now. So this derivative, as it reads, will be that derivative, or that first derivative, is equivalent to the denominator times the derivative of the numerator, and the order matters because this is in the formula. Subtraction is part of the formula. Okay, on the other side of town, it's the first function times the derivative of the second function. And the part everybody always forgets, it's the derivative squared. And you will use this to differentiate. Now, notation wise, you may see this as y prime is equal to b times t prime minus t times b prime all over b squared, which is really easy to remember. Thought. Or slightly longer derivation where you have dy over dx is equal to the denominator function times the dt over dx, which is basically the derivative of the top function, minus t times db over dx, which is just simply the first function times the derivative of the denominator, and all of that over the denominator squared. Typically in Pearson, they don't even ask you to factor out the denominator, just FYI. So let's do a few examples of this one. Let me know when you're ready and you have this copied. And if you learn these two patterns really well, you should be in good shape. All right, so this is the question I'm going to throw your way. So we'll call this example 4. In example 4, they're asking us to find the first derivative given f of x is equal to x squared over 2x minus 1, and you don't have to factor the square of the denominator for now. All right, so following this rule, remember this is your t and this is your b, so this is t of x, this is b of x. Again, I like to follow this rule where if I'm looking at this as if this is t of x, then the first derivative right below it. Same thing with b of x, its first derivative right below it. And so if t of x is x squared, then its first derivative is simply 2x. B of x is simply 2x minus 1. Its derivative is simply 2. Okay? So if you remember the formula, it's the opposite of the product rule, because it's this first. Notice that I have 2x minus 1 times 2x. So it's the opposite of the product. This one goes this way. I go opposite as well. So it's minus, and I like to do this because it's still a product. And I know this is simple because it's just simply x squared times 2. But it's going to be the negative of that, and if by chance you have a binomial or a trinomial, you may forget that that negative is going to affect all the terms following. And yes, all of this is over 2x minus 1 squared. You don't have to do anything to it. So doing a little distribution, so this times this and this times this, you should end up with 4x squared minus 2x minus 2x squared, and all of this over obviously 2x minus 1 squared. And this simplifies, right? Because 4x squared minus 2x squared is simply 2x squared minus 2x over 2x minus 1 squared. You don't need to simplify further. That's not too bad, is it? Let's finalize. This part may get a little irritating because my first thoughts are immediately 2x is common. Why aren't we factoring 2x out here? Why isn't this x minus 1? Why? And will it make a difference? Because if my denominator happens to have an x minus 1, well, guess what? They cancel, right? So your mind starts getting very creative at this point. So stop where you think you need to stop, and then test it. If it doesn't work, try to work it out a little bit more. But normally this is it. All right, I have a ton of examples I want to share with you, so I'm running out of time. So let's look at B. Example B. They're giving us in this one y equals t squared minus t over t cubed plus 1. Find. They just trying to get you used to the notations. So what you gonna do? I call that CPT. Okay, if you remember what I said, you're going to remember to multiply this way first, right? Opposite of product. and then lastly this way with a subtraction in the middle over b squared, right? So we're going to start with 2t minus 1 times t cubed plus 1 minus, I like a bracket, this will be t squared minus t times 3t squared. And of course all of this over the b squared, which would be t cubed plus 1 squared. Okay, if I use distributive property, we could do that. This is going to give me 2t to the fourth minus t cubed plus 2t minus 1 minus 3t to the fourth plus 3t cubed. And of course all of this over the magic denominator t cubed plus 1 squared. And now we simplify. Remember that negative is going to jump in here. It's going to change this. It's going to change this. So everything goes away otherwise. And now we simply do the math with our common exponent values. So this is going to give us negative t to the fourth, which is basically this and this added together. This actually should be positive. This is going to give us, because that's negative. Remember, we're distributing this times the negative, and so you have a double negative coming up here. That's why this is positive. This is going to give you positive 2t cubed plus 2t minus 1. And just think it's only an hour. That was a joke. All right, over t cubed plus 1 squared. And you stop there. Which way? Okay, the next question, I have a couple of ways you can approach this, but I'm running out of time. So let me see if I can, what happened? You good? Okay, let's look at example C in this particular one. So they're giving us a function and they're asking us to find d over dx given x squared minus 3 over x squared. So there's a couple of approaches here. If you'd like, I'll show you both. I'm going to do method 1. And in method 1, that's the long way to do it. So let me do method 2 because you haven't seen that one yet. So this is where we simply can divide. So that means that we're going to split the fractions, so it's x squared over x squared minus 3 over x squared. And so this reduces. This reduces to 1 minus 3x to the negative 2. You remember that guy? When we were doing differentiation?
Oh, yeah.
So if we take the derivative, so we do d over dx of 1 minus 3x to the negative 2, then this becomes 0 minus 6x minus 2, right? Because we're going to multiply that. So it's going to give us a plus 6x to the negative 3. Remember, take away 1. rewrite it, it'll simply be 6 over x to the third power. I feel like I'm torturing you. All right. I have 2 more quick examples after this, and we're done. Okay, so let me see if I can squeeze this in. So if not, worst case, I'll start with this next class on Monday. So I'm going to start with example 5. And we're again finding derivatives. So we're going to find the first derivative. That's all I'm asking. And they're going to start us with this question. They say f of x is equal to 3e to the x over 1 plus e to the x. So if we follow the typical method in this case, remember this is your t of x, this is your b of x. So we want to find the derivative of the first equation and the second equation. So I know that t of x is equal to 3e to the x. I know that b of x, that's going to be equal to 1 plus e to the x. I need the first derivative of this term, which is what?
E to the x.
It's just 3e to the x, no change. What about this derivative? It's just e to the x. Given that, when we cross multiply, so we start here, right? Remember? So this is 3e to the x times 1 plus e to the x minus, and again, I like a bracket. It keeps things neat. Here's 3e to the x times e to the x, because that's the second half of the equation. That's going this way. And now we divide by 1 plus e to the x, and that is squared. And this is going to cancel. So if I multiply 3e to the x, I get 3e to the x. I want you to see it so you don't. 3e to the x times 3e to the x e to the x, right? Because that's what happens when you multiply there. Minus 3e to the x e to the x. What happens there? Those two cancel. You're left with 3e to the x and all of this over our denominator, which was 1 plus e to the x squared. Okay. Ready? I could do one more and then we finish this on Monday if that's okay with you.
Yeah.
Because I feel like I'm hitting a wall. I'm looking at a couple of faces and nothing's going in. Am I wrong? Yeah, no, not right. Yeah. Let me just do one more example and we stop. And I'll finish. It's only just one more example after this. Okay, example B. I don't lie, I promise. All right, so we're gonna find the first derivative of f of x equal to natural log x over 2x plus 5. Okay, so once again, we're gonna start with that notation, right? This is our t of x, this is our b of x. So I'm gonna start with natural log x here and 2x plus 5 here. The derivative of natural log 1 over x. the derivative of 2x plus 5, simply the 2. So I'm going to cross multiply, if you remember, opposite direction, right? So this becomes 2x plus 5 times 1 over x minus this product. So I'm going to put a bracket. We're going to call it 2 times natural log x. Keep it simple. And of course, all of this over 2x plus 5 squared. Okay. So you end up with 2x plus 5 minus 2x natural log x. And all I've done right now is just distributed. And all of this is over the 2x plus 5 squared times x. This is the 1 over x part of the natural log. That's what's left here. I'm going to stop there. Is that okay? No crying? I will start with some examples and then the last example, and we're done.
So it's like 5 multiply 1 over x. It's going to be 5 over x or just 5?
Just 5 because I dropped the x down. If you notice, this is, in other words, this value right here, this x, oops, oh, dude, this x, so you see here is this x, so you see here. You're literally throwing it down. Because it's stuck with the natural log x. It's not the same term.
No, but why is it 2x? Isn't it 2 natural?
Because this is 2. This is 2 right here. This is the 5 right here. And then this is minus 2x natural log x. Because remember, natural log is 1 over x, so you multiply it out, 2x natural log x. That goes back to 3, 2. That's what I'm doing right here. And this also will drop. This is why we will drop it. So if you're multiplying, in this case, what was it? It's 2 times natural log of x. If you remember, it's this term always ends up being an x term. So this will, whatever this will be 2x natural log x. I showed you that in example, hold on. In the book, we did this in section 3.2. This was like number, I want to say this is example, go with example 3. Example 3 in the book, example 4, well, that's more like a word problem, but example 4. So again, just remember, this is, I might run this one. Make sure I'm not skipping a step, hold on. I don't like skipping steps, so sometimes I do. So yeah, so this times this is 2x plus 5 times the natural log of x, 1 over x. So that minus the product 2 times natural log x. Correct. And so when you multiply this derivative, or this result here, becomes 2x. That was one of the steps that I showed you guys when we did natural log x. It becomes, like if I have 3 natural log x, and I work out that product, this will become 3x natural log x. I showed you examples of this in 3.2. I'll look for more if you need a little refresher. Have you done the homework?
Yeah.
Because the homework will help you master this.
This is not work in the book.
Yeah. Because you also have to remember, you're gonna multiply by x over x to get rid of this also. This is how we end up with the x down here. Because at this step, we're gonna multiply x over x to get rid of this. Which is why we drop this down. I keep saying we drop it down, but it's more like I'm canceling it. I'll go over this again. So this is example 5b. I'll go over this again. No worries. Let's just put it at this memory for me.
That'd be good.
You too.
When I said it